Let's do a couple of examples of hyperbolas. We're going to graph each hyperbola, find the foci, and write the equations of the asymptotes. So let's start with this one. X squared over 16 minus y squared over 9 equals 1. So here's our equation of our hyperbola. So we can start by finding the vertices, and in this case, you'll notice they will be the x-intercepts. If you make y 0 and solve that equation, you would find that you get x equals plus or minus 4. So let's come over here and go 4 in the x direction, both in the positive direction and the negative from the origin. And we know we are going in the x direction 4 units because it's underneath the x squared. That 16 is underneath the x squared. You take the square root and you get 4. So those are our vertices. We know now that the hyperbola is going to open right and left. But we don't know how wide or narrow the hyperbola is, so that's where the asymptotes come into play. So we're going to go in the y direction 3, square root of this number right here, and we're going to go down to negative 3. Now those aren't points on our hyperbola, but those are points that are going to help us get the asymptotes. So we draw our central box that goes through those points. And the asymptotes are the lines that contain the diagonals of those, the asymptotes are the lines that contain the diagonals of this box. So let's draw again. And now we can draw the hyperbola because those asymptotes are our graphing guides. So our hyperbola goes toward this asymptote and this one, and similarly over here. And we have our hyperbola graphed. Now we do need the foci. Those are inside the branches of the hyperbola. So they're here and here somewhere. And remember, they are c units from center. For this particular equation, we know that a squared was equal to 16. So let's just jot that down up here. A squared equals 16. It is always a squared is always the denominator of your first term when it's written in standard form. The term that is positive has a positive coefficient. Our b squared is our 9. And we know the relationship between a's, b's, and c's with a hyperbola is this. A squared plus b squared equals c squared. So we have 16 plus 9 equals c squared. So if we solve this equation, we have c equals plus or minus 5. So we know the foci are 5 units from center. And since the origin was our center for this problem, we know that the foci are here at 5, 0, and here at negative 5, 0. Last, for this problem, we need to write the equations of the asymptotes. Now those are just lines, and then the lines go through the origin, 0, 0, so their y-intercepts are 0. So really, we only need their slope. Their slopes are, starting from here, rise over run. You can look at the picture and see the rise is 3 and the run is 4. So my slope for this particular asymptote would be 3/4. Similarly, for this asymptote, the slope would be up 3 and left 4 for a slope of negative 3/4. So we know the equation of a line that goes through the origin would have a b value equal to 0 if we just look at it in slope-intercept form. So our equations would be y equals 3/4 x plus 0 for this asymptote, and y equals negative 3/4 x for this asymptote. And we have all the information for this particular equation on our picture. Let's do one more. Let me erase this. I'm going to need more space for this one, so I'm going to erase the directions, but we're going to still find that same information. So for this one, we're going to let the equation be y minus 1 squared minus x plus 2 squared over 25 equals 1. Now notice this time our y squared is first. So this equation is of the form y squared over a squared minus x squared over b squared equals 1. And when we have our y squared first, we have a hyperbola that opens up and down. So this one has also been shifted off the origin. So just like we did for circles and ellipses, we can use these values to determine center. So let's start with that. Our center, we do have to take care. It is easy to just grab the ordered pairs using this value followed by this value, but remember, the x-coordinate is with the x and the y-coordinate is with the y. So for this one, the center would have an x-coordinate coming from here. So the opposite of this number, so negative 2, comma 1. So when we're graphing this one, let's come over here. And we'll come over here to negative 2, 1. And there will be the center for our hyperbola. Now underneath our y squared, it will tell us how far to go in the y direction. Notice that the denominator is really 1 there. We take the square root of 1. That is 1. So we go 1 in each direction, or up and down from the center. So from here, I go up 1. And there's going to be one vertex of my hyperbola. And I go down 1. And there will be my other vertex of the hyperbola. And since I'm thinking about it right now, this is my a squared. Let's just jot this down for later. Our a squared is 1, and our b squared is equal to 25. Remember, when we're looking at an equation in standard form for a hyperbola, the denominator of the first term is your a squared. It may or may not be the larger of the two denominators. But now I need to figure out what the asymptotes look like so I can draw my hyperbola. I can find my central box by going in the x direction, the square root of this value. So that means 5 from center. So from here, I'm going to move 5 units, 1, 2, 3, 4, 5. Puts me right here at 3. And 5 in this direction, 1, 2, 3, 4, 5. Puts me over here at negative 7. So now I can draw the box through those points. And it's not really the box that's so important, but the asymptotes that that box generates. So I draw my line that contains those diagonals. So here, whoa, that doesn't look very much like a line. A straight edge would have been very nice. And here, I do the same thing. Right, so there are my asymptotes. So my graph looks like this. Remember, those asymptotes are your graphing guides. The graph should head toward those asymptotes. So my hyperbola looks something like this. So there's my graph. Next, I'm going to find the focal points. Remember, they are inside the branches of the hyperbola. They are c units from center. We know center is at negative 2, 1. So we need to find c. Remember the relationship between a's, b's, and c's for a hyperbola is a squared plus b squared equals c squared. So if my a squared is 1 and my b squared is 25, I'm going to come over here and insert a little space. I have 26 equals c squared, or c equals plus or minus the square root of 26. So from center, I'm going to go up square root of 26 units, and I'm going to go down square root of 26 units. But center is at negative 2, 1. So I need to add that square root of 26 to the y value right here. So the foci are going to be at negative 2, comma 1 plus the square root of 26, and negative 2, comma 1 minus the square root of 26. And last, I'm going to find the equations of the asymptotes. Now we have the information about the slope just by looking at our graph. Notice the rise of 1, the run of 5. So the slope for this asymptote is 1/5. Similarly, the slope of this line is negative 1/5. And we know that the lines don't go through the origin this time. So our y-intercept is not the 0, 0. But we do know that the lines go through the center, which is the point negative 2, 1. So I'm going to use my point slope form of the equation of the line. Let me remind you that's this y minus y1 equals m times x minus x1. Right, where x1, y1 is any point on the line and m is the slope. So if we pop these numbers in to this equation, we have y minus 1 equals, and we have 1/5 times x minus negative 2. And this is the equation of this asymptote. Now the equation of the other asymptote is very similar, but we have a slope of negative 1/5. So those are the equations of our asymptotes. I'm going to leave them in point slope form, but if you needed to change them into other forms like slope intercept form, you could distribute the 1/5 and add the 1 if you needed to. All right, I hope that helps you working with hyperbolas.